Last stage, we taught the harness to plan and orchestrate work across many agents, but every one of those agents hit the same wall. The model only knows what it was trained on. So, how does an agent answer a question about your code written last week that no model has ever seen? Here is the whole problem in one picture. The model is a sealed box. Inside are its frozen weights and one open slot, the context window. If a fact isn't in the weights, the only way in is through that slot. So the entire game is find the right fact and slide it into the slot before the model answers. That's Retrieval-Augmented Generation, and the naive version is just 4 steps. Take your documents and split them into chunks. Turn each chunk into a vector, a list of numbers that captures its meaning. Store those vectors in an index. Then, at question time, turn the question into a vector too, and pull the chunks whose vectors sit closest to it. Step 1, chunking, is where most people quietly lose. The unit you retrieve is the unit you embed, so each chunk has to stand on its own and answer a question by itself. Prose splits cleanly into 500 to 1000 token passages with a little overlap so context survives the cut. But code should never be split by line count. You split it at function and class boundaries using a real parser, so a function never gets sawed in half. Step 2, search, has a trap. Vector search is brilliant at concepts and paraphrase. Ask for auth and it finds login, but it's blind to rare exact tokens like an error code or a function name. Old-fashioned keyword search is the opposite. Perfect on exact matches, deft to synonyms. Neither alone is enough. So the best systems run both and fuse the results. Let me show you the full pipeline end to end with that fusion step in the middle. On the left, your documents flow into the chunker, get embedded one chunk at a time, and land in the index. That's the offline half, and you do it once ahead of time. Now a question arrives. It splits down 2 paths at once. The top path is dense vector search. Find the nearest neighbors in meaning. The bottom path is sparse keyword search. Find exact token matches. 2 ranked lists come back. Here's the elegant part. You can't just average the 2 scores, a cosine distance and a keyword score live on totally different scales. So instead you fuse by rank. Reciprocal rank fusion adds up 1 over rank for each document across both lists. A document that ranks high in either list floats to the top, and the incompatible scales never have to agree. That fused list is recall oriented. It casts a wide net, maybe 50 to 200 candidates. Most are roughly right. Now the second stage earns its keep. A cross-encoder re-ranker reads the question, and each candidate together jointly and rescores them. It's far more accurate than the index time embedding, but it costs a model call per candidate, so you only run it on the shortlist. The survivors, the top handful, get pasted into the prompt as context, and the model answers an open book question. Cheap recall first, expensive precision second. That 2-stage shape is the workhorse of production RAG, and SourceGraph's Cody is a clean real example. It pre-indexes whole repositories, chunks them at the method and class level, attaches the function name and signature to each vector, then retrieves and re-ranks before it answers. But a vector index is only as fast as the trick that lets you search millions of vectors without checking everyone. Next time, we open up the vector database itself and the trade-off triangle hiding inside every one of them. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.